The first two subspecialty groups and scope of responsibility of geotechnical engineering are the geomechanics and the geostructure. The geomechanics embraces the realms of theoretical soil mechanics and rock mechanics. It also includes the practical aspects of soil and rock behavior based on empirical observations and their applications for interpreting soil and rock behavior. It also includes the study of constitutive behavior of geomaterials, methods of geomechanics, testing methods of the soil and rocks. It may include the most advanced geotechnical and geophysical in situ testing techniques. In constitutive behavior of geomaterials, the geomaterials may include rock, clay, granular materials, treated soils, and industrial waste. In particular, as environmental requirement and engineering availability of byproduct wastes, the efficient recycling of waste for geotechnical infrastructures are natural geomaterials and treated geomaterials. Geomechanics is the study of how subsurface rocks deform or fail in response to changes of stress, pressure, and temperature. Geomechanics is also the study of the way in which rock stress, including how and when faults will develop. The finite element method, finite difference method, and the boundary element method are the continuum methods most used in geomechanics. Using advanced unconventional in situ, which is soil formed when the parent rock is broken into small fragments, and laboratory soil testing method. The testing methods include stress path for unsaturated soils, when the conventional soil testing methods include field and laboratory determinations of physical, chemical, and mechanical properties of soil and rock. Testing methods for soil and rocks includes abrasivity testing for rock and soils, compression test, penetration test, advanced laboratory, field observations, and soil classification. The most advanced geotechnical and geophysical in situ testing techniques provides the advantages of generating a more accurate assessment of subsurface conditions, allowing for better data analysis and informed geotechnical design. Advanced geotechnical and geophysical in situ testing techniques includes in situ monitoring system, advanced resistivity tomograph, submarine soil investigation, and advanced geotechnical exploration. The geostructure deals with the soil and rock as the ultimate foundation material. It studies the interaction of the soil and rock with the structures and the load imposed on it or within it. It is also concerned with the study of the soil and rock stresses and their effects on the underground structures. This includes the foundation engineering, earth structures, tunnels and underground structures, and retaining system. Foundation engineering is the application of soil mechanics and rock mechanics in the design of foundation elements of structures. These include strap foundation, shallow footing, pile driving, pile drilling, construction of foundations, and deep foundations. Earth structures engineering involves the analysis, design, and construction of structures that are composed mainly of earth materials. This growth is due largely to increased involvement in designing various types of earth structures for the resources industries, to the development of increasingly large hydroelectric projects, to the need for more freshwater storage and diversion schemes, and to the need for transportation, communications, and other facilities in areas where the natural earth materials are occasionally subject to mass instabilities. Earth structures includes coffer dam, earth dwellings, dike, seawall, earth dam, and fortress. Tunnels and underground structures is an underground passageway dug through the surrounding soil or rock and enclosed except for entrance and exit. Some tunnels are aqueducts to supply water for consumption or for hydroelectric stations or are sewers. This includes subway tunnels, underground tanks and reservoir, tunnels through mountains, subterranean structures, underground basements, underwater tunnel aquarium, sewer system, underground mining and travel system, underground bunkers, and underground weapon, bomb, and nuclear storage facility. Retaining systems are engineered to retain soil and rock. They are commonly used to accommodate changes in grade, provide increases in rate of way, and buttress to the toe of slopes. Retaining system includes retaining walls along hills and mountains, seawalls, retaining wall design, modular block wall, revetment walls for river, grouted riprap revetment wall, gabions, and retaining wall along highways.